employee-based logins. And so they decided what they were going to do is start requiring employees to use token-based 2FA to gain entry. They didn't specify what kind of token-based. This could mean TOTP. This might mean that they're requiring their employees to use YubiKeys. I'm not totally sure. I haven't followed up on this, but it basically means that they're using some kind of more secure form of 2FA instead of just using SMS. But I wanted to kind of explore this because not all users of Reddit or employees of Reddit are created equal. And so I think this is something that we start to get into this kind of like the threat model of the authentication process and seeing how are different people at different risk factors, like why are Silicon Valley employees more risky than, like my dad and that kind of thing. And so, maybe for something like Reddit, they're requiring their employees to use token-based 2FA. Maybe like if you start to look at the users of Reddit, moderators, maybe they require them to have 2FA. It doesn't specify what kind of 2FA, but perhaps they are required to use it. And then for everyone else on the website, you have optional 2FA. This is not my recommendation for Reddit. This is just to start to get you thinking about like how different types of people at different companies are using these types of things. I did mention this before, but I think the thing to keep in mind about employees is that like employee 2FA is usually managed by, or might be managed by an IT team instead of like the developer team if you have a distinction between those two. And there is a difference in the relationship there, right? Because you are able to, say you're not going to get paid this month unless you like take this YubiKey that I handed you. You have that relationship where you can hand them something physical. There's a bit more of a symbiotic relationship there because they're more willing to take the extra mile to protect the company that they're working for, hopefully. But you could take this, the idea of this Reddit model and apply it to other industries too. And so if you were working in something like banking, maybe you start to delineate this based on the balance. And so you started to see this with things like cryptocurrency exchanges with people, maybe they didn't require it right when you signed up, but as soon as you like purchased any Bitcoin, they might require you to turn on 2FA or require you to turn on 2FA to do anything with your account. And so, if you have a balance over $250,000 and require token-based 2FA, and then as your balance gets less and less, and when you first sign up, maybe don't require it right then. And the takeaway here is really that the risk profile of your users is specific to your business, and so I can't really tell you what to do with your business without understanding what your business is. But you all work in security, and so I think you're especially trained and well poised to think about these types of trade-offs and risk and how you can set up your customers to be the most secure. And I do like to point this out that SMS 2FA is still better than no 2FA at all. I think it does get shit on a lot right now, but it is low friction, there's no app required, and you're going to see a higher usage of it than you would if you were requiring something else. And there's data to back me up on this. So 4 days ago, Google released this research that was saying they found that an SMS code sent to a recovery phone number helped block 100% of automated bots, 96% of bulk phishing attacks, and 76% of targeted attacks. So even if it was a targeted attack, Google found that SMS 2FA was still effective over 3/4 of the time. And so, yeah, it's not great, and yeah, there are risks with it, but it's still better than nothing. And if that's all that you can offer to your customers, it's still something that I think is pretty valuable. But that's not to say that it is the most secure option. So if you're using something like push authentication, still 100% of automated bots were blocked, but then that starts to go up. So 99% of bulk phishing attempts were blocked with something like push authentication, and then 90% of targeted attacks. And so there is still ways to get around all these types of two-factor authentication. I think if somebody is motivated enough to try to hack you, the Mossad's gonna Mossad type idea, there's only so much that you can do to stop a nation-state attack against your accounts. But this is a quote that I like to include in most of my talks because it's usually always relevant, and that's from Cormac Hurley, who is a security researcher at Microsoft, or was at the time when he wrote this paper. When we exaggerate all dangers, we simply train users to ignore us. And that's from a really great paper that he wrote called The Rational Rejection of Security Advice by Users. And in this paper, he talks a lot about how, security advice and security posture and a lot of these recommendations that we have for our users are asking a lot of time of them, and we're asking a lot of people when we ask them to make their accounts more secure. And so it's really like our job as the people that are building these websites to help make that as seamless as possible for them and help to try to keep them secure without trying to ask too much of them and try not to scare them too much, because otherwise they're just going to start to ignore us. So I do like to avoid victim blaming users. I mean, if somebody does have a password that's 123456, maybe there's some stuff that we can do to stop them from using that type of password. It's easy to tell people to just use a password manager. It's advice I've given people. I think it's not bad advice, but I do think that there's more that we can do in the industry to help set our users up for success. And so I think as developers and as security professionals, we need to think about things like adding reasonable password requirements to your site, offering one-time passcodes when it makes sense, and I think they're starting to see a lot more innovation like this. Like with Slack, the magic links are a really good example of a way that you're starting to get around people that, like, if you don't have an easy way for people to type in a password, they're going to start changing their passwords to something that's less secure. You know, if you're Netflix and the only way for somebody to log into Netflix on the TV is to type it in with their remote, they're going to change their password to be a 6-character insecure password, because if they're going to have to type that in all the time, they're not going to want to do that. I might have been a person that did that once. And then you also want to have a seamless user experience for the 2FA. So I hope I've sparked an interest in securing your users and giving you an idea of just what kind of security you might need. This is my alter ego as a stock photo. I really like her. Come find me after this. I'm going to stick around if you have any questions. Once again, my name is Kelly Robinson, and thank you for listening. And I'm going to hand it over to Brad. Do you need this?
Probably better just denying it. Were you getting more? No, I have it over here. Cool.
Can everybody hear me okay? Thanks for having me. Appreciate Tom reaching out. I'm going to talk about confidence as code in the cloud testing kind of space. So hopefully this is something that's applicable to you if you are a cloud security engineer. If not, hopefully it opens your mind to what the cloud could be in terms of a security posture and things. So a little bit about me. I did some pen testing, and for the past 3 or so years I've been focused on container orchestration security, specifically with Docker and Kubernetes. I have run a global scale capture the flag exercise, 1,500 participants for 7 straight days in AWS on Kubernetes. So to say that we flexed everything that we could on Kubernetes is an understatement, but that's what made me fall in love. And so I've spent the last 3 years helping people move their workloads to Kubernetes, a lot of it on Google Cloud as of late. But I'd like to step back a little bit and talk about maybe some of the differences of why this gets me excited and hopefully then gets you excited as well. So there's 2 talks that I think the PDF will be shared, or the links to the slides will be shared so you can get these links. But the talk I did at KubeCon on hacking and hardening Kubernetes, and then a talk I did at Black Hat, which was accidental, I promise. I didn't think about wearing this shirt, on detecting malicious cloud account behavior. So we're going to play a little game of agree or disagree. This is really easy. All you have to do is raise your hand for the item that you agree or disagree with here. Agree first and then disagree. So do you agree securing workloads in the cloud is easier than on-premise?
What does raising your hand mean?
Agree. Do you agree? Okay, and disagree. Wow, split. I was hoping it would be a little bit, okay, here we go. Agree, security teams have better tools and processes in the cloud. Okay, one or two less hands, your hands?
Tools or processes.
Tools and
Available.
processes.
It doesn't mean they're using them. They're available.
Who disagrees? Who thinks
Are
that's...
you talking in the ideal world or in reality?
Here and now.
In my security team?
In your team, if you're less, okay.
I don't know, I'd say better, I'd say different.
Okay, different. Okay, so a few, all right, split room. This is good. This will be controversial in a nice happenstance way. It's easier to prove that cloud infrastructure is secure. Agree. Aha. 2.5. I'll give you a third there. Or disagree. Who disagrees? Okay, that's the third and final one. I'll come back to these. Easier to prove. Well, I hope this talk helps in this regard. If it doesn't, I'm sorry. So, traditional versus cloud native. We were talking in the break room there a little bit what that difference is and why it's just apples and oranges. I like to break it down this way when I think of it from a security perspective, not like, yes, there's infrastructure as code and DevOps and all the good stuff, but stepping back from the pen testing days, I remember going into an environment, and then the very next year, it was the exact same IPs, the exact same vulnerabilities, the exact, nothing had changed despite all of our efforts and all the money they spent. You can't say that about a cloud environment. It really will not be like that. So the thing about traditional environments, I call traditional just hand-built, handcrafted, not cloud native, not built by APIs. It's built by humans with love and care and playbooks and follow this, then click this and install. Then you have your Windows system and then start installing or DC promo, what have you. That is just not the case in a lot of environments in the cloud. It's all built by code if you're doing it correctly. We can talk about maybe not doing it correctly a little bit there later. I think the key thing, the first thing people run into is IPs having identity versus not. So an IP address in a traditional environment has some sort of location to it or physicality. It's this switch holds this subnet that has these IPs and there's a top of rack router, et cetera, et cetera. You sort of know and can pinpoint where that is, so systems that live on that rack or switch might be in that subnet, they might have an area where they are. In cloud native environments, IPs are purposely ephemeral. They don't mean anything and should never be relied on for something, except to say at that moment it happened to be at that IP. Configuration issues are typically patched live. So you log into production, you suck it up, hopefully have people reviewing what you're doing, and you're patching and fixing and hoping it works. In cloud native environments, hopefully you're editing the upstream source code that deploys your infrastructure, deploys your application, and just hitting the same button you always hit, which is redeploy. The upfront payment versus pay-as-you-go is kind of obvious. We talk about CapEx and OpEx all the time with cloud. But the last four, I think, kind of point to where I'm going with the talk a little bit. The static architecture diagram versus a dynamic one. I remember going into pen tests and vulnerability assessments, and I'm like, show me your diagram. And they would go, roll it out on the conference room table, be like, this is our trunk, et cetera, et cetera. Now that literal whole piece of paper and everything in it can be built in tens of minutes with code and destroyed in 10 minutes of code, right? That's a whole different ballgame when it comes to scoping and understanding what you're trying to secure, what the relationships are. Compliance frameworks fall flat on their face in a cloud native environment. They don't even speak container. They barely speak VM. So there's a lot to go here, and I'll try to talk about how we can kind of work with that. That's one of the more interesting things I do in my day job in helping folks square peg, round hole. Security mostly understands the environment in a traditional environment. Like it doesn't move that quickly. It absorbs over time. You're looking at diagrams. It starts to make sense. You start to touch systems, and you get a sense of the world. In cloud native environments, that could be a 50-node cluster. An hour later, it's a 500-node cluster, and then it's back down to 50. What happened to those 450 nodes? Well, they did work and went away. So it's just a whole different understanding of behaviors of systems. And not jabbing at any specific vendor here, but there's traditional, tried and true security vendors you have long-standing relationships with. They know your environment. They know those workflows. And then you have just upstarts that are just finding the little holes and gaps around cloud providers that are filling in security holes in the cloud native world. That's really what's happening. And then they start to get bought out quickly as they show promise. So there's a little bit more churn in that space, a little bit like we've always been a Cisco shop, we've always been a VMware shop. It's not really that case anymore, so there's a lot more churn. So back to the agree or disagree. I would say in terms of securing workloads in the cloud being easier than on-premise, it's entirely dependent on skills and expertise. If you don't speak cloud, you don't live cloud, your team's going to struggle. And securing that's even harder, orders of magnitude harder. And it really depends on the approach. There's the lift and shift approach, which is I have a VM here, one of them. I'm going to move it to the cloud here, one of them. Or there's this thing does 5 different things. Let me break it apart and have each independent thing be on separate VMs. Maybe it's a microservice architecture. That's a fundamentally different approach. It actually gets a little bit more complex when you do it that way, although it's the correct way in most cases. And then shipping velocity and complexity make it harder. How many of you are working with people who deploy code on a daily basis? Like they're literally making changes every day, right? It's just that that amount of change causes the mental model to never be correct. You're always playing catch up. What change did they push? Did they add a firewall rule? Oh, okay, no, that completely changes the game, right? You do it 10 times a day. 10 teams, 20 teams, 50 microservices. You get the idea. I think security teams, in terms of having better tools and processes, I argue the building blocks are better. The polished, easy UI, not so much, right? Because of the rate of change. It's hard to keep up in making those products. But basically, everything's an API. That means you have the ability to hit an API too, to do your job as a security auditor, security reviewer, security engineer, etc. Even a vulnerability assessor, any one of those titles, if you can hit the API, you can know everything that you need to know. And again, I talked about the rapidly changing and maturing landscape. I would say proving cloud infrastructure is secure is, I don't even know if I could write those words. It was really hard to type that out because it's incredibly difficult to say that. But it's not saying something we shouldn't do. We should try to do this. But compliance frameworks, I'm aware, yes. Yes.
It's not possible to prove that a computer is secure.
Fair
Period.
point. So going with that is secure enough, secure for your needs, right? So compliance frameworks starting to be cloud aware.
Not possible to make proofs about the security of a computing system.
Okay. So compliance frameworks are starting to be cloud aware, meaning there's only a few that I know that speak this specific set of APIs, this specific settings. Okay? So NIST is coming. I know there's a lot of churn in that area. There's a lot of research, a lot of good work being done there. But is it follow these steps for this specific API, for this specific set of services? Not there yet. Auditors don't, this is something I didn't realize until I went through it. Very smart, very gifted, very talented auditors that just don't have hands-on. So they can't help you pull the context over and understand what you're trying to do. So you're saying, no, it's like a VM. It really is, except for this one change that can really put a wrench in their ability to sign off confidently and say you met the controls, you met the intent. And comparing security posture to on-premise is like apples and oranges. So a lot of folks are hybrid. So they have set models, set processes that they use to hit their internal systems and validate that they're ready, certification and accreditation. You turn those guns and point them at your cloud infrastructure and they all fall flat. They just fundamentally operate differently. So I think it's harder to prove that it is secure enough for your needs in that way. Yes, sir?
You're going to argue something like EKS is totally different from OpenShift or Kubernetes?
Am I sorry? I'm sorry.
I guess what I'm saying is your auditor should be able to figure out an on-premise equivalent, right?
I didn't hear the first part. I apologize.
I guess your cloud services are the same as the services you run on-premise. So, like, the argument that your auditors can't figure out the differences, I mean, I kind of think that should be the intelligence of your auditor, right?
Yeah, so I think what you're getting, hopefully I'm going to rephrase it, that what you're doing on-premise and what you're doing on cloud, there's a lot of similarities for certain things like Kubernetes, EKS, OpenShift.
I mean, EKS is Kubernetes on a, like if
Yes.
you go Amazon,
Yes.
that is what it is, so. isn't there that shoehorn?
Things like serverless, cloud storage, just fundamental permissions understandings, fundamental roles, access controls. It's similar enough that maybe you and I would look at it and go, yeah, that makes sense. An auditor go, wait, I've never used that. I can't say that that's correct. Right? Let me go back and talk to somebody and then come back and say yes. So there's that added bit of friction for them to be like, oh yes, I understand what you're doing. Please continue on with the audit. Right? I like to think this translates to a lack of confidence. That's how I like to describe it, right? I can't validate that I'm hitting certain targets, certain needs, baselines, compliance frameworks, whatever your bar is set at, it's really hard to validate that you're hitting those reliably, consistently. And one of the ways, in my argument, one of the ways to get there for a lot of the low-hanging fruit. Now, I'm going to preface this by saying, confidence through testing, you can't test everything. You can never be fully automated for everything. But if you're trying to be efficient and you're operating at some level of scale, you have to automate as much as you can so that you can focus your human efforts on the precious things that you want to spend time on. My custom app, the thing that makes me money, this website. All the base infrastructure that goes along with it, I would love to automate all of that configuration so I know what the state of it is. It doesn't drift. It's hitting my baselines, and then work on the very specific vulnerabilities that I am focused on, the real threats. I pulled this not to be specifically technically accurate, but just to show the list of the open source security testing model. What are all of these to you? They differ, right? But they're all things that in some way may or may not apply to your application, your infrastructure, your architecture. And arguably, you want to do as many of them as often as you can. Well, we can't do that, time and money, right? So how do we get the 80-20 or the 90-10, if you will? One of the best things that I've found, one of the least, I shouldn't say, one of the things that clients I work with don't focus on is making sure that the foundation of their infrastructure as they deploy it is at a set baseline that they can validate over and over again as they build the layers on top. It's really easy to go through a quick start and say, click, 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 boom, I'm using serverless. And you're like, what did you build that on? How do you validate that that is in the conformance of what you want it to be before you move up the layers? And so one of the things I try to work with a lot of infra security teams, InfraSec, those kinds of folks that try to straddle a little bit of security, a little bit of infrastructure in cloud environments. The approach that I try to take with them is to look for the efficiencies and commonalities. Most of the time they're doing 2 or 3 of those testing types, not all 8, maybe a pen test here or there, or they have an internal red team. But fundamentally, a lot of the work, the heavy lifting that's done for all of those testing is based around the inventory. Getting an understanding of the architecture, the diagram, what you have at any given time is a lot of hard work unless you're doing it with code. So I try to look for those efficiencies and say, well, you repeat this process here. Let's write some code that validates that process so that when you make 1,000 of them, you just iterate 1,000 times of that same set of tests. Yes?
Sounds like an internal test you're referring to versus an external test.
Internal test versus, yeah, so I'm talking more as like a blue team that's validating what we're doing, hasn't drifted, new person to the team didn't come in and just open firewall rules or change ACLs and things. Start small and iterate quickly. A lot of folks want to go, I have to be NIST compliant. And they say there's 1,000 controls. I'm making that number up. Let's do all 1,000. How do we do that? You got to step back and say, start with one thing. What's the one thing that's most important to you right now? Codify that. Get good at that one thing. Do the next thing. Pick another question that's high value. Something that maybe the board or the organization will take notice of that you responded to quickly, right? And keep iterating. And something I'll talk about a little bit about embracing automation, about how you work and develop these tools. You're technically writing software, so you should be writing these in a way that follows software development lifecycle processes, storing in source code, making it so that the next person on your team who comes on, who's onboarded, doesn't have to ask you specifically while you're on vacation, how do you run that test? It should be well understood that it's very easy for somebody to come on board, check out that software, follow the document, which is pretty quick, and say, here, I can be off to the races. It avoids the bust factor problem. And then perfect is the enemy of good. I mentioned there's 1,000 tests that you want to check for in a compliance framework, 80% of them can be automated. Let's automate all 80%. Step back, go for the most important ones first, start there, mature as you go, right? So one of the orgs was like, we don't want to do this because it only gets 75%. I'm like, that's 75% that you know are configured correctly, that you're following all the time. And if you automate that, you don't have to revisit those all the time. Your code is doing that for you. I use the word DevOps in a very specific context here. Don't get bent out of shape on the definition. Everybody's is different. Oversimplifying here, Dev and Ops, there's a fence, a proverbial fence in the middle. They're throwing code over, and Ops is just dealing with the pain. They say, the way that you're handing me this code is awful. I can't make it work. I have to reboot it every day by hand, etc. I can't go on vacation. The pain gets stopped when it hits the wall going backwards. So there's no shared pain. Dev doesn't feel anything. They're like, yeah, we're shipping. Let's go for some golf on the weekend, right? And Ops is deploying on a Sunday morning. One of the key benefits of DevOps is that that's a shared pain and a shared success. So because Dev is working together with Ops, and it looks a little bit more like this if you're doing it correctly, there's shared code and shared pain. There's also a forming of culture. There's a forming of automation, measurement, and sharing. That's the CAMS model, C-A-M-S. Security can be there too, but it's a little bit different. There's not as much symbiosis in the way that you're shipping or deploying. There can be. We're just a lot further apart than when Dev and Ops started, right? Dev has a goal of getting features into production. Ops has a goal of getting features in production. Security has a tendency to say no. So it doesn't really help with the velocity factor. You're not sharing that, that forward momentum often. But it can if you do it correctly. I'm not saying I have every answer on that. I'm just saying I've seen it work and I've seen it not work pretty well. So speaking from the internal testing standpoint, if I'm looking at what I've built, you know, as an infra team, cloud deployment, cloud DevOps, Ops, NetEng, all these teams are deploying resources in the cloud, whether it's low-level things like networks and subnets and VPCs, or it's high-level order things like functions, containers. It doesn't really matter. Most of them, in terms of, it doesn't matter the difference, they're all deploying via APIs. And what you can do, you can get a lot of mileage out of asking those APIs for the state of the world. It's something, it seems, I feel like it's weird stating the obvious bit here, but there's so much information embedded in the APIs of the state of an object that was created via that same API. Who would have thought? So it doesn't matter who's creating that VM. They're defining all the settings when they say, go create it for me. As an auditor, you come by a week later, you go ask the settings, and they're correct. There's a treasure trove of information if you were to just ask everything about everything. And that's what I'd like to show you a little bit about. One of those examples is a firewall rule. Everybody understands this mental model. Used to send a ticket to a firewall engineer team. Hey, please add this port to that firewall over there. I don't even know which firewall it is, but can you add it? You know, 3 weeks later, yep, it's been added. That's how it used to be. Now it's a little bit better, hopefully, in that you're putting a ticket to some code, a PR to some code, and that's saying, please add this here. Somebody approves it, it gets automatically deployed. Fundamentally, it's somebody saying, here's some settings I'd like you to send through, and the API says, that makes sense, you're authorized, and I'll make that happen in the real world, and I'll send you the response back. As an auditor, we can go say, great, let me list all the firewall rules. I'll just ask the API. No more, hey, can you take a screenshot of your PIX configuration or your checkpoint configuration, Palo Alto? Like, hopefully those days are dwindling, just for the sake of accuracy and pain, honestly. I put these in a little bit early. I probably could put this set of slides at the end, but I like to start with what success and failure looks like, and then I'll show a little bit of the code. Clarify your definition of compliance and what you're testing. Is it a capital C compliance or lowercase c compliance? Is it hitting some specific framework or objectives, or is it just our best practices that we make at our org? Start very simple and start very small. One thing. Recently, the RDP 3389. The biggest question people ask in Google Cloud Platform is, how do I know which VMs are Windows and are exposed via TCP 3389 anywhere? It's just a great thing to know, right? You want to be able to answer those questions. and codify and automate all those configuration tests that you possibly can. Nobody likes to test. Nobody likes running tests. I remember talking with QA folks that would run the same web tests on features, and they were just bored out of their minds. But I guess, right? Like, I personally don't think that's a great thing to do long term in terms of value. And make the results visible of when you test. Hopefully you're testing at every change or any significant change. That might be 10 deploys a day, that might be 10 tests a day of your infrastructure, of that posture. It might be once per hour, once per minute even, if it's a high rate of change environment. But making the results visible is kind of harder than it looks. Most people think, what, a PDF, an Excel spreadsheet? That's a path to failure, using spreadsheets. I work with Google Docs and Google Sheets on a daily basis, and whenever somebody says, all right, I'm gonna go track it in this spreadsheet, that's one more thing I have to like pay attention to and add to my work queue, right? That's not a great place for tracking things at tens of thousands. Even 50 is annoying. So if you're using spreadsheets, stop for a second and look, is there a better way to track this? Is there a better way to report this? Such that nobody has to literally sit there and go through line by line of spreadsheets. Yes, you said something. Yes?
What argue if you develop your test harness with kind of developer UX in mind that allows them to use it? You get to see more out of it and they'll use it more.
Fantastic. I think I'll try to recap. So make the user experience of running your tests as seamless as possible for your developers, your operations folks. Maybe they're not security specifically. Absolutely. That's the shifting left part I put here at the bottom, moving left in the software development cycle earlier. Best thing you can do, if you can, is get it during CI, right? So they check in, I want to make a change, you put it in source control, the continuous integration system goes, hold on, let me go check some things, run unit tests, whatever. If that's a change to infrastructure or applications deployed, if you can test it there, that's the earliest and best place to do it. If you can't, you can test it later down the line in maybe the staging environments, et cetera. But that's shifting left. But be careful if you do that too early. In other words, if they're not ready, if their CI pipelines, how they get code into production is brittle, manual, not reliable, they don't focus on it, maybe the builds are broken here and there, you're not adding a lot of value to them, even though you're doing your job. Like, oh, I'm testing every time they check in. That blocks their build, or they just ignore it. It's not adding a lot of value. Yes?
So that was why I said make the UX for the test harness, so that they're incentivized to use it because they know how it works.
Yes, incentivization to yeah. So the UI experience, as a nice side note.
Well, user interface, whether it's API or the UI, whatever.
Sure. Yep. How they interface with your testing harness and get results back should be as natural as possible to their normal workflow. So if they use a CLI tool or a web UI, try to fit in, if you can, your showing of your results and fit into their workflow. So it's not another spreadsheet to go look at. It's something that's part of their daily tracking. So, yes?
Who should, you say make the results of the tests transparent? How transparent?
I think it differs. I mean,
How many people should see it, or who should see it?
If it's the question is who should see the results?